Hello, my name is Yolanda Casiero. I'm a project manager at the Edmonton Water Treatment Plants. I am providing you with an overview of our flood protection initiatives that we're embarking on. I'm going to give a bit of a project overview for those of you who are not able to attend our in-person sessions. We'd like to present this information to you because your feedback is important to us, and we'd like to provide as much opportunity as possible. So I'll just dive into a bit of context for this project. You can see in the photo here some pretty significant flooding that happened down in Calgary. That was around 2013, and that flood prompted our insurance provider to take a look at our water treatment plants and assess for any vulnerabilities. It was identified that there's some submersion risk to some critical equipment at our water treatment plants and also the potential for some structural damage, especially to our treated water reservoirs. We'd like to be able to continue to provide you with that safe and clean drinking water that you're used to. And in order to do so, we need to protect the water treatment plants from damage. We're also looking to the future. We've assessed some of the impacts of climate change on the North Saskatchewan River watershed and are looking at how climate change could impact extreme weather events. This project is part of our long-term plan from both a flood protection perspective and protection for extreme weather events that might be coming our way in the next 30 years. So looking again at some of the damage that happened in Calgary, it was quite extensive. It prompted the provincial government to initiate the Alberta Community Resilience Program. We applied to that program based on some of those vulnerabilities that were assessed at our water treatment plants in conjunction with some technical assessments that we did internally. And we were successful at receiving some funding there. As well, the federal government has a disaster mitigation adaptation fund that they have initiated, and we have applied to that program and also received some funding. So in total, we've received just over $21 million from those two programs, and that accounts for nearly half of the total estimated project cost at this point. So just taking a look at our distribution network, you can see two red dots. The one right in the middle is the Rossdale water treatment plant, and the one to the southwest is E.L. Smith. And you can see from this map that we don't just service the city of Edmonton, we service a fairly wide network into some regional communities. In total, the service area for the Edmonton water treatment plants is nearly a third of the population of Alberta. So the goals of this project: we'd like to ensure that we mitigate any potential damage to our water treatment plants, and we'd like to ensure that we can resume potable water treatment as quickly as possible after a flood event. The design level that we're looking at is 1 in 500. So it's tempting to think that that means that a flood that big would only occur every 500 years, but really it's just a way to talk about probability. So 1 in 500 means that there's a 0.2% chance that that volume of floodwater could roll through the city of Edmonton in any given year. And as the years go by, that probability accumulates. We've also added 1 meter of freeboard. So that's a bit of a safety factor to account for anything unexpected in our modeling or in climate change. And we just want to ensure that whatever we install is suitable for the long run. We're also taking a multi-year approach to this project. That was by design. We would like to ensure that there's enough time to effectively engage with the communities that these barriers may impact. So we're looking for that feedback, and we're wanting to ensure that we've got enough time to incorporate it. So what does a 1 in 500 return period flood look like? You're looking at Rossdale right now. You can see the Remax field, the Rossdale neighborhood, the Rossdale water treatment plant itself, and Fire Station 21, all labeled on this map. And under that red circle there is our low lift pump house. So that is how we're taking water in from the river into the water treatment plant to make it potable and distribute it out to the communities. In that area, we have pumps. We also have some electrical equipment there. And that electrical equipment both services those pumps as well as some other equipment in the vicinity. And it's very important that that stays dry. That's not easy or fast to replace. And if it were to go out of service, we would not be able to draw water in from the river anymore. And this next red circle is the treated water reservoirs on site at Rossdale. There's 2 of them there. And you can see that those are inundated with floodwater coming across. That floodwater would certainly not be clean. It would have a lot of residue built up, as floods tend to drag everything that they come across into the river with them. And we would not want to have any of that infiltrate into our reservoirs and contaminate the treated water. So it's important to keep water off of that. Also, from a structural perspective, those roofs are not necessarily rated for the weight of that additional water on top of them. And just moving on to E.L. Smith, you see that 1 in 500 inundation at E.L. Smith as well. The 3 little white roofs and then the L shape underneath of it, that's our filters and clarifiers. Under the red circle there, that's our low lift pump houses, again, drawing that untreated water out of the North Saskatchewan River and into the treatment plant for purification. This is the buildings that house our additives that we use to treat that water. And these are our on-site treated water reservoirs. So the water doesn't get on top of those ones, but it certainly surrounds them. So we're looking at 3 types of work for this project. We are working hard to identify which ones are our critical assets, critical being necessary for the treatment process to work. Also, anything that's difficult or very long to replace is something that we certainly want to ensure that we have protected. We don't want to be out of service for a very long time, and ensuring that those assets stay safe is a top priority. Also, we have a number of pipes that collect water from various areas within the treatment process and from the plant site itself, and those outfall to the river. They're open pipes for the most part at this point in time, so that means if the river water gets high enough, it can just back right up through those pipes and either inundate the site or contaminate the treatment process, the treatment train. And then finally, we are looking at developing barriers to protect that treatment site from that inundation that we just saw in those maps. So our requirements for design, we certainly need effective flood protection. There's a number of standards that we need to comply with. For example, the United States Army Corps of Engineers have some flood protection guidelines and standards that they have published, and those are based on a lot of history, engineering, and experience with flood fighting in North America. We'd also like to ensure that we have permanent structures in place to provide ongoing and immediate protection for those water treatment plants. And finally, we need to ensure that we remain within our budgeting constraints. Right now, we have a concept of a combination of flood walls and earthen embankments. There's certainly some room for movement between those 2. However, there are some areas where we're restricted to one type versus another, and we'll go through some of that in our site-specific presentation. Also, we'd like to try and balance our technical requirements, our budgeting, our environmental impacts with input from the community, and that's why we're here today. We'd really like to hear from you, how you'd like these barriers to look and feel, how we can integrate them into the community, how we can integrate them into the existing naturescape. Your input is very important to us and will help us to decide how and where we can provide augmentation to the barriers that we need to put in place. I'm just looking at timelines. So those first 2 categories, that critical asset protection and that backflow prevention, so those pipes that we need to stop water from coming back through, those are projected to be complete towards the end of 2023. Those, for the most part, are work within the plant sites themselves and may not be noticed by most of the general public. And then the embankments, the barriers, walls that we need to put to prevent that inundation from the river. That's a much longer timeline, and that's to ensure that we have enough time and space to have some effective engagements and conversations with the community, and to balance those competing priorities that we were talking about in terms of cost, environmental impact, input, and from the community, and our technical requirements. So in terms of where we're at right now, we're in our phase 1. So we're looking out to the community for feedback on some preliminary concepts to understand what kinds of things we can consider, or what kinds of things we should consider. Once we've got some of that feedback, we can refine some preliminary designs that we can bring back out for further feedback and discussion. And then finally, we can take those the feedback from those preliminary designs and do some detailed engineering as to what the final design might look like. And we'd be looking into spring of 2022 for that. So as I've mentioned, we really want to hear from you. There's a phone number on this slide that you can call, an email that you can send your feedback to. And of course, we have 2 dedicated pages on our website, one for Rossdale and one for E.L. Smith, that will have some additional information specific to each site and ways that you can get involved. Thanks for your time. Thanks for your listening.